Okay, so we are reviewing for our Unit 5 test today. Let's do one of each type together. You guys ready? Here we go. I will, but let me do one first. So you're gonna have some problems like this, where all you have to do is simplify. All I would recommend you do, guys, please stop talking when I am. You're gonna handle the numbers first, then worry about the variables. Look at your numbers, 30 over 24. Can you reduce that fraction like a normal fraction?
10 over 6.
Yeah, 6 goes into both, 5 times and 4 times. So my new fraction will be 5 over 4. Now let's look at the variables. You have p to the 4th over p to the 5th. So I'm going to be left with p to the 1st on the bottom. That's it. You're finished. That's it. Okay, jump to one like number 4. This one, please do not come in here and just start canceling things out. That is not how this works. Guys, really almost for every single problem, your first step is to do what? Factor. Factor whatever can be factored. Up top, you could take out a 6. On the bottom, what does that factor into?
-8 plus 3.
Right, factors a -24 that have to be a -5, would be a -8 and a +3. So now that I have factored top and bottom, now I can cancel out. If I have any matching binomials top and bottom, the whole thing, and I do, the n-8s are going to cancel. Can I cancel that 6 with that 3? No! That 3 is part of a binomial. You can't touch it unless you had an identical binomial upstairs. If on the bottom you had factored out a loosey-goosey, I don't know, let's say a 12, and there was just like a 12 hanging out in front of here, then I could cancel those two. But as it stands, I can't do anything. So I'm done. That's it. Final answer. No. So real quick, on 3, you would have to factor a 10 out of the bottom. So if you took a 10 out of the bottom, now you have a 30 over a 10 and they're both loosey-goosey and you could cancel those. All right, so we might as well just finish this one. So that would just be 3 over n plus 5. Okay, when we get to something like,
How'd you make it 32? You took a 10?
I took out a 10 and then I reduced 30 over 10. What?
So you can do top and bottom and take something out?
Yeah, you can take wherever you can factor something else, you factor it out.
Well, I thought since you can't, it's 10 doesn't exist.
I took a 10 out of the bottom, so I turned it, it's not 10n plus 50 anymore, it's 10 times n plus 5.
Oh,
All right, jump to something like 5, I guess. There's nothing, guys, you have to be quiet. I have almost no time. There's nothing to factor on number 5. So you get to go right to canceling. Anything in the numerator can reduce with anything in the denominator, same fraction or not. So I see a 2 and an 8. Can I reduce those? 4 and the 2 just becomes a 1, so I don't really care about it. 3 and the 9. Yep, and then the n's. If I have one n on top and n to the 3rd on the bottom, what's up? N squared on the bottom. Nothing else cancels, so I multiply straight across. That's 4 over 3n squared. Done. If you,
why'd you lose an N on the N cube?
I had n upstairs and n cubed on the bottom. So if you have 1 n on top and 3 on the bottom, aren't you left with n squared on the bottom? Okay, so let's jump to something like 11. A division problem.
It's not cube.
Cube change flip. That's always, if it's division, right? You're doing keep, change, flip. So I'm gonna keep the first fraction as it is. Don't change anything. Yet, change to multiplication and then flip this one over. Okay, so now step one is done. I did keep, change, flip. Now what do? Now I factor everybody. Factors a -6, they have to be a +1. A +3 and a -2. Yep, so that one's done. Nobody else factors. Can I cancel anything? What? N-2s, because it's the whole thing that matches an N-2 with a whole N-2. Anything else? N+3s cancel it also. That's it. What am I left with? 5. If that 5 had been in the denominator, what would my answer have been? 1/5, not 5, right? It's 5 this time because 5 is in the numerator. All right? Easy peasy. Flip it over. Okay, let's do one like 13. These are the easy ones. When you're dividing by just one thing, it's not like a plus or a minus. I'm just dividing each of these thingies by 6b in this case. Each one down the line. And I just reduce each fraction. That's all this is. 5/6 doesn't reduce, so I leave it as 5/6, and it would be b to the b squared in the numerator, right? The next one, 30/6 is just 5. B squared over b, b. The last one, just 3, right? Is the b's cancel? Bless you. That's it. That was easy. That's it. That is your answer. Finished. 15, a little bit more annoying because what do you have to do on 15? That's the long division. How do you know when to do long division and when not to? Because look at what you're dividing by. Right, there's 2 things in there, so now I have to do long division. So real quick, I'm gonna put k + 1 on the outside. And then on the inside, 2k squared plus 8k plus 1. Do I need 0 placeholders in this one? No. And then here's the process. I'm asking myself, what do I multiply the first term here, k? What do I multiply that by to get 2k squared? 2k, so I put it up top, and I'm gonna multiply 2k times everything out in front. And notice how I'm lining them all up. All the exponents line up. Once I multiply it, then I have to subtract them both. 2k squared minus 2k squared cancels. That's gone. But now I have 8k minus 6. 2k is 6. Boy, tongue twisters today. Bring down your +1, and then you just repeat the process. What do you multiply k by to get 6k? 6. So up top goes a +6. Multiply +6 by what's out in front. And then just like before, after you multiply, you subtract. 6k's cancel. +1 minus 6 leaves me with a -5. There's nothing left to bring down, which means that's my remainder. So if you recall how we write the remainder, because this one's negative, -5 over what you were dividing by, k + 1. This is the answer. That's it. So that is long division in a nutshell. All right, next up, we are adding and subtracting. So 17, we'll start off easy. What do I do with this? I just add the numerators. They already have common denominators. That's the key thing that I need here, but I already have it. If my denominators match, I'm literally just adding the numerators together. So combine like terms. You would have 7x plus y over the common denominator, 6y. Is that a final answer? Yes. Don't you touch it. The only way that that's not a final answer is if something factored out of the top and it could cancel with something in the bottom. That's not the case here, so we're done. Okay. Ooh. Oh, all right. There it is. I'm like, why aren't there anywhere it's All right, so let's jump to something like 20. So this one, I do not have common denominators. So I need to get them so that they are. I noticed they both already have a y, so that's good. So I really just need to match 5 and 3. I'm gonna turn them into 15 y's, aren't I? So I'll multiply this first one. I like to cross out the problem number so I don't get confused. The first one just needs to be multiplied by 3 over 3. And the second one needs to be multiplied by 5 over 5. So now my fractions really read 9x over 15y minus, isn't that 20x if I multiply that through?
Yeah, 20x over 51.
And now now it's a problem where the denominators match, so I just minus the top. Negative 11x over 15y. Is that a final answer? Yep, nothing cancels, nothing to do, we're done. Real quick, on something like 21, how would you even begin to tackle this one?
-1.
You would think, but if you
No.
multiply this by -1, you get negative a minus 4, and they don't match.
By each other.
You gotta multiply them by each other. So it's a little bit more annoying, but not so bad. So a plus 4, a plus 4, a minus 4, a minus 4. Just make sure you are distributing. So my new numerator over here would be 5a squared plus 20a over my common denominator. Okay. Distribute this one, 3a squared minus 12a over my common denominator. Now it's the same as, now it's an easier problem, right? Because the denominators match. I just add those numerators together. So we're going to get 8a squared plus 8a all over a plus 4a minus 4. Is this a final answer? I can take an 8a out of the top. Let's see what comes out, because maybe it'll cancel with something downstairs, but maybe it won't. I don't know. We don't really know until we do it. So that would leave me with a plus 1, right? So does it cancel with anything? No, but I didn't know that until I did it. So I can do what? Okay. All right, and then the last thing we did were, let's just jump to 25 in the interest of time. These ones, these equations, you have to get all of your denominators to match. Ooh, sounds worse than it is.
Except for the triangle.
Right, now I have 3 of them I gotta get to match. 25. So I still want to start by factoring the denominator, because that's the easiest way to get the denominators to match. So I can take out a 3n.
That's what I'm saying.
Yeah, but if you didn't realize, yes, you're right. In the end, I will be. So now that I look and I have them all factored, I see, oh, hey, look, they all have a 3 and they all have an n minus 2. The only thing that I don't have is the middle needs an n. That's it. So I'm just going to multiply the middle one by n over n. And now everybody's denominators match, correct? All right, so then I just do
Would
the
n over-
numerators.
So, I'm sorry.
No, go ahead.
Would the n over n not go into the n minus 2?
What do you mean go into?
Well, because you got 3 and then n minus 2 right there.
If you were to multiply all this together, doesn't it get you 3n squared minus 6n? You multiply it all together? As long as the denominators are going to match, you don't actually have to do the math out. I just need to do it in the numerator. So in the numerator, look at my equation. I have 1 plus 1 times n is just n equals 2. Oh my gosh. And then I just solved that equation, which is so easy. My answer is, that's it. Is 1 an okay answer? Yes. How do I know? I look back and I ask myself, if I put 1 in here, is it going to make my denominator turn to a 0? No, it wouldn't. What numbers would have made my denominator turn to a 0? 0 or, someone said it. Want to be positive 2? Positive 2. If you had done the math and your answer had come out as either 0 or +2, you'd actually have to throw it away because it would make a denominator turn into 0, but +1 doesn't, so it's fine.
Which shows 26.
Yeah.
Sure. 26. Oh, so 1, couldn't I just rewrite 1 as 1/1 to make everybody be a fraction?
Do that by B.
And then I just want to multiply that by b/b. Yeah. Yeah. Can't you take any number and just put it over 1? Yeah. So now everybody has a denominator of b. And then my equation would just be 1 plus 1 times b is just b equals 5. So in this case, the answer is 4. You want me to try one more real quick?
Yeah, is there gonna be a problem like that on the test?
There could be. Let's do 24 real fast. In order to get the common denominator, I'd have to
X over X and 3/3.
right, this middle one needs 3/3. And this last one needs x over x. So now if I do the equation, everybody's denominator matches. I'd have 2x plus 4 plus 6 equals x. Right? And now I'm just solving this. So I can combine them some like terms. Minus that 2x over. So -10. That's it, guys. So I am going to post this along with the answer key on Jupyter. You don't have to do any of it because I'm giving you the answers. So, but I highly encourage you to try some more so you make sure you're ready for tomorrow. Joe, you had a question? Sophomores are getting dismissed like right now. If you're not a sophomore, you will stay for a little while. I believe you bring your bags, yes.
That's crazy. I
Hold
said.
on, wait for that to talk.
That was tricky.
Sophomore?
Yeah.
When you're going to an assembly.
Yeah.
Oh, all right. Thank you.
Yep.
Get out of here.
You have my-